Arkansas, Texas, AEM, they have these chamber because they're more specific research for poultry meat. They do lots of for Campylobacter, they need those chamber. I do some more research for Campylobacter, but I'm not that rich, so we're still using these jar to grow. Okay, so how are we going to grow this jar? How are we going to put the bacteria there? These are the plates we put it there. Then we put a gas pack. Okay, we put a gas pack. We add like 10 ml water. Then will be reacted, generate hydrogen and carbon dioxide. Because we want to take out of the oxygen, so we need to react it with the oxygen. So what we do, we use a gas pack to generate hydrogen. Then the hydrogen reacted with oxygen becomes water. Now we want to let this reaction happen more quickly. So we need to add some of the catalyst. So we had something on the top of the corner or the bottom of the lock screw that's called palladium. This is like a catalyst. Okay, let the reaction happen more quickly. Now later on, how do we know the oxygen is all gone? We need some indicator, is that right? So we put the methylene blue. It's a dye. The methylene blue will become colorless when the oxygen is gone. If the oxygen is still there, the methylene blue becomes blue. Or sometimes we're using another chemical called resazone. The resazone is pink when the oxygen is colorless when the oxygen is gone. Okay? So the basic idea for this jar, how we going to take out of all the oxygen? We generate hydrogen. Let the hydrogen to react with the oxygen. And we want that happens more quickly, more frequently. So we add a catalyst, which is the palladium. The palladium is right on the top of the lock screw. And then how do we know the oxygen gone? We need to add an indicator. It's could be resazone, it's also could be methylene blue, like in our slides. Okay. Okay, last one. Biofilm formation. This is something happens on our surface. And I mentioned it briefly before, when we are using laser confocal microscope, we could see 3D images. We want to test the biofilm. So what are the biofilm? First of all, bacteria will grow on this type of surface. Although there is no nutrients, there is a limited amount. But why bacteria can grow? Because more or less there's some water. Okay? If you measure the water activity here, might be 0.56. Although it's dry, they still have some water bacteria can use. So then they grow. They started to grow. When they grow, some of the bacteria will be deposition because they're going to die. Some of the bacteria will be absorbed. Then the absorbed bacteria on the bench, what they do? They are very poor. When they poor, they do help with each other. I don't want to say this politically, okay? I'm just giving you an example. Poor people always grab together, help with each other. The rich people always individually, is that right? Just an example for bacteria. So the bacteria right here, they're very poor, so they help each other. So they connected with each other. Now they need a nutrition, is that right? I have some glucose, you don't have a glucose. Some like I have one candy, you don't have a candy, I want to give you a candy. What they do? They do a communication, which is called cell-to-cell signaling. A terminology called calling sensing. Okay, there is a terminology for that. In our food micro class, we talk about that. Here we just briefly call it calling sensing. So they like, I have a candy, you don't have a candy, you don't have a candy, I go split into three. I go through the communication. Okay, so I give you. That's called a calling sensing. Okay, then more and more they are there. They grow. They start to replicate. And they start to grow. What is going to happen? Accumulated polysaccharides. It's a matrix. The matrix is going to become more and more heavy. Of course, some of them detached, some of them accumulated. If more and more accumulated, what's going to happen? Become a matrix. And then the matrix is very, very strong there. They become resistant to the antimicrobials. I give you an example of this bench. They may not feel biofilm very easy. Happened often is on a meat plant. In those of the metal container, or those of the cutting board surfaces, if you do not do a sanitizing very well, the residual bacteria there, one cell could grab another cell, then the biofilm will be all covered on the surface. Then next day you do a sanitizing. You're using chlorine, contrary ammonium compounds. It's always failed because you need a much more higher concentration to kill those biofilms. Okay. Now why we need a laser confocal microscope? Because we need to see how thick the layer is. Some of them is 3D format. Therefore, we're using the laser confocal microscope. We could see the color spectrum. We also could see how heavy the layer. We could do analysis. Okay, that's for the research. So that's for the biofilm. And said very easily is a matrix of the bacteria formed on for the contact surfaces. Usually, the poor the nutrition requirements, the easier bacteria to have the biofilm. And what is the example of a pathogen really easy to have biofilm? It's not E. coli, not Salmonella, not Listeria, it's Pseudomonas. Pseudomonas is a sporage bacteria. It's very easy to feel biofilm. Is actually that one. Okay, compared to Campylobacter, this guy is easy to have biofilm. Usually, if they connected together, let's say a poultry meat cutting board, the biofilm will be very strong. Okay? And that's some of the examples. Okay, I'm going to end up here. Because next week, these are very important terminology. We're going to explain to you those selective media, differentiated media. Lots we can talk about. Okay, so we're going to end up here.